So my name is Wei Fan. I'm going to present the first part of the work we conducted under thread 1. And then Daniel will then present the second part of the work. Okay. So next slide, please. So Ali, can you turn to the next slide?
I'm in the next slide.
So after the third one here, so I think 28, right? Yeah.
I'm in slide 29.
29. So I cannot see that. Yeah, sorry. Okay. So so you can see the team member here. We have Ali from NC State, Daniel Findley, also coming from NC State, Stephen Jiang from NC-CAV, and we have two past members, Stephen Bird and Nick Norville from NC State, but they left us, I think, last year. So next slide, please.
Yes.
So the objective of this research is to first conduct a literature review, and then select suitable intersections for case study. And the third is we're trying to develop simulation models to measure the performance. And then the fourth goal is to analyze the impact. And next one, please. And then we're going to analyze the revenue impact of CAVs in North Carolina. And Daniel will present that part of the work. And then we're going to develop a final report, which is something we are doing that right now. Next slide, please. And then we have some publications under thread 1. As you can see here, 2 publications on these slides. Next slide, please, Ali. And then we have held some seminars in the past as well. Next slide, please, Ali. And then this kind of like a slide show the hypothetical intersections that we used for the conduct of our research. So this pretty much follow the procedures in highway capacity manual. Next one, please. So these slides basically show the car following model that we adopted in our research. As you can see here, we use the intelligent driving model to simulate the behavior for human-driven vehicles. And then we use ACC vehicles and also the CSCC car following models to simulate. So when AV vehicle follow human-driven vehicle, we use ACC's traffic flow model. And then one CFV follow another CFV, then we use the CSCC car following model. Next slide, please. And then these slides basically show a list of basic parameters that we use in our models. For example, we have time gaps between CFV and CFV. We have 0.6 seconds. And for human-driven vehicle, the time gap is 1.9. And then autonomous vehicle follow another human-driven vehicle, then we have 1.1 second as the time gap. And we have a list of papers that showed here. That's where those parameters come from. Next slide, please. And then these slides basically summarize the list of parameters we used in our models. And next slide, Ali. So according to HCM, we know that saturation headway is currently calculated as the average headway between the 5th and the 15th passenger car in the standing queue for intersections. And that's how we calculate the saturation headway in our research. Next slide, please. So these slides basically showed the saturation headway in our model. As you can see, when the connected and autonomous vehicle penetration rate is 100%, then we have 0.934 second for exclusive through lane. And then exclusive left lane, we have 1.174. For shared right, we have 1.335 as the saturation headway. So this table basically shows the lane-based saturation headways at a different market penetration rate of CFEs. Next slide, please. So this sort of like the headway adjustment factor we calculate based on the parameters we obtained in our research, as shown in the last slides. For example, when the CFE penetration rate is 1, then we have saturation headway as 0.441 as the headway adjustment factor. Next slide, please. And then these slides show the capacity adjustment factor. For example, when the CFE penetration rate is 100%, then we have about a double capacity, 2.268. So 2.268 times as much higher as the capacity. Okay, next slide, please. So these slides basically show the maximum throughput we run based on different demand. They are highlighted in red, as you can see here. That row basically show the maximum throughput based on the traffic demand at 5,400 as the traffic demand. Next slide, please. And then these slides basically show the intersection capacity based on different market penetration rate of CFEs. And then next slide. So table 1-7 shows the traffic performance under saturated traffic flow on a different market penetration rate level. And next slide. So as you can see here, the CO2 emission, the fuel consumption, and also total waiting time increased slightly initially, and then kind of like leveled off in the middle, and then increase sharply later on as the market penetration rate becomes higher and close to 100%. And next slide. So figure 1-7 shows the maximum throughput with 100 market penetration rate of a CFE, so which is 1.7 times the human-driven vehicle capacity. So that means the capacity is calculated at the intersection level. Next slide, please. So figure 1-8 shows the layout of the hypothetical intersection we used in our study. And then you can see as a fixed demand level changes, then we have a transition in terms of the total waiting time. Next slide, please. And then so we see the transition point somewhere between 0.6 and 0.65. And we will present the numerical results in the next slides. So here comes to the next slide, please, Ali.
Yes, I'm
so as you can see, so 0.2, 0.6, which means a light traffic demand scenario. As you can see, the total waiting time remains stable throughout. And then we get to the medium demand level, which is a 0.65, 0.8. So the total waiting time decrease. Basically, the reason is that we got a more vehicle that can clear the intersection. And then we have 1.1 all the way to 1.5. So we have oversaturated situation because the traffic is highly congested. So all those cars pretty much get stuck at the intersections. That's why they remain stable, sort of like that. And then later on, the condition change from oversaturated to be medium, traffic level, and then you can see the significant decrease in terms of total waiting time. Next slide, please.
Yes, I'm 50.
Okay, so we are currently working on an isolated intersection in Charlotte here, another case study, which is a real-world case study. And then we are working on another intersection, 2 adjacent intersections in Greensboro, North Carolina as well. So that's pretty much what I have. So I would like to turn it over to Daniel. Thank you.
Great, good morning. And I would like to acknowledge our team, both at ITRI and with Stephen Jang, and working on this particular task, looking at transportation revenue collection. So on our next slide, we'll see the important data sources that we're using. And so if there's anyone ever notices something on this topic that comes out, please shoot it our way. And we want to make sure we're including all the relevant information. And we've worked closely with NC-DOT, Bert DeSico and Amna Cameron in particular, collecting some of this information and making sure we're getting NC-DOT specific information throughout our processes. On the next slide, we'll see a comparison between, in these pie charts, North Carolina on the left, the US on the right. And we do see that North Carolina's user fee revenue is more reliant on motor fuels tax and license fees than the average state. And traditionally, I think this has been a great thing. We like, from an economic perspective, to have the people using a facility, people who benefit from a facility, also pay for that facility. And so traditionally, as we know, the motor fuels taxes and license fees are pretty good user fees from that perspective. But as we know, and as we're exploring, and the purpose behind of our exploration of this topic is that's coming under attack in the future with changing vehicle fleet and how we move and power our vehicles. So one of the things that we're talking about and thinking about are, CAVs in particular, with their effect on these different funding mechanisms. The highway use tax, which is essentially a sales tax. We're unsure at this point if it's going to impact, how it's going to be impacted by CAVs. Higher revenue per vehicle because of the higher cost, but it may be offset by smaller overall fleet size. So that's an example of one of the things we're taking a look at. On our next slide, we do see some challenges, some additional challenges and roadblocks. The near-term CAV forecasts, we believe, at the state level are less reliable than the near-term EV forecasts. And so one of the things I'll talk about coming up here is the trade-offs between looking at CAVs and EVs. Obviously, not all EVs are CAVs, but we do think the majority of CAVs will be EVs. The largest revenue challenge to NC-DOT in the short to near term is likely from fuel economy, changing from either developing from EVs or to EVs, or improving the actual fuel economy of combustion-powered vehicles. And we do think that CAVs in that short to medium term are a distant third behind that fuel efficiency and increased EV adoption. One of the things that we're exploring and doing some analysis with is whether or not EVs are net contributors or not to NC-DOT's revenue. The EV registration fee, it's possible that it exceeds the fuel tax lost on the vehicles being replaced. In particular, if you think about replacing a small, very efficient internal combustion engine with an EV, they may actually pay more under that fixed registration fee depending on the mileage driven. So that's something that we're trying to evaluate and consider in our analysis as well, to make sure we're comprehensive. Looking a little bit on the next slide into the changes in fuel economy. This is when I mentioned the fuel economy being a larger threat, and we've seen some federal announcements recently that may even escalate this further than we expect. This is looking over a 20-year time period in changes in the average light-duty vehicle. These vehicles still roughly weigh the same, but continue to get more efficient. So we're getting less revenue per mile than a decade or more ago. The next slide is looking out a little bit further, looking at CAFE standards and how we expect those to change. Again, those recent announcements may impact how quickly this grows, and it may even be accelerated relative to what we're showing here. Next slide looks at EV adoption, and again, this is where we think, in terms of revenue, the EVs themselves are actually the larger threat in the near term. It's nice that North Carolina was a leader in that electric vehicle fee that comes in their annual registration to make sure that we're trying to offset those vehicles no longer being fueled by gas. So that is something we're paying attention to. And finally, our next steps. We're working on finalizing these revenue forecasts and really getting into the details for these alternative funding mechanisms and the current ones. And really our difficulty is attempting to separate CAV impacts from EV impacts. There's a lot of overlap there. The EV forecasts seem to be a little more robust, as we would likely expect them to be. And so that's been one of our primary focuses recently. Our last slide just has our references. If anybody has any, again, anything to add, please feel free to share that with us. And at this point, I think we're turning it over to Thomas Chase to talk on thrust 2.